Welcome to Algebra 1, Unit 5, Lesson 5-6, Inverse Variation, Part 2. I'm Mr. Pilarski. Our objective today is I will be able to compare direct and inverse variation. Example 4T, determining direct or inverse variation. Decide if each set of data represents a direct variation or an inverse variation. Then write the equation to model the data. To determine if we have an inverse variation, we want to test the product x times y. That's the constant of variation, so this is an inverse variation. To determine if it's a direct variation, we want to test the ratio y divided by x. If all of the products are the same, then we have an inverse variation. If all the ratios are the same, then we have a direct variation. So let's check this out. Is it an inverse variation? Well, for it to be an inverse variation, all of these products have to be the same. That would be 3 times 10, which is equal to 30. This pair would give 5 times 6, which is equal to 30. This pair gives 10 times 3, which is equal to 30. All pairs give the same product. 3 times 10, 30. 5 times 6, 30. 10 times 3, 30. Therefore, this is an inverse variation. And the equation is going to be in the form y is equal to k divided by x. We take this 30, which is our k, and we substitute it in. Y is equal to 30 divided by x. So this is a part of our solution here, that it's an inverse variation, and this would be the equation for that inverse variation. We don't even need to test it if it's a direct variation, because if it's inverse, it's definitely not going to be direct. Let's look at part B. This will be our inverse variation, which we find by the product x times y. So let's find out if it's an inverse variation. Well, the first one's 2 times 3, which gives 6. The second pair gives 4 times 6, which is 24. So we don't even have to test the third pair. Since the first two aren't the same, we know it's not going to be inverse. So let's determine if it's a direct variation. And determining if it's a direct variation, we test the ratio y divided by x, or y to x. In this case, we'd get 3 divided by 2, or 3 over 2. Now, 3 over 2 can't be simplified. In this pair of data, we have 6 over 4. Now, 6 over 4 can reduce. It reduces by a factor of 2. If I take 6 divide 2, that gives 3. And if I take 4 divide 2, that would give 2. So this ratio simplifies to 3 to 2, or 3 over 2. We need to test the last pair. That would give 12 divided by 8, or 12 over 8. And like this pair reduces by a factor of 4. 12 divided by 4 gives 3, and 8 divided by 4 gives 2. So each pair of data gives the same ratio, 3 to 2, or 3 over 2. Therefore, this is a direct variation. And we're going to use the equation y is equal to kx, substituting this constant of variation, 3 over 2, or 3 halves, in for the k. So y is equal to 3 halves k, or 3 halves x, I should say. So our parts of the answer, this is a direct variation. And remember, it's a direct variation because the constant of variation, y over x, is the same for each pair of data. And here's the equation for the direct variation. Example 5T, inverse or direct variation. Explain whether each situation represents a direct variation or an inverse variation. Part A, you buy several souvenirs at $10 each. The way I like to do this, or illustrate this problem to my students, is with a little pattern. If I take the $10 cost and I buy one souvenir, that's going to be equal to $10. If I buy a $10 souvenir, or if I buy two $10 souvenirs, that's going to be equal to $20. That should be a 10, not a 20. If I buy $10 souvenirs and I buy 3 of them, that'll be equal to $30. If I buy a $10 souvenir and I buy 4 of them, that'll be $40. In this table, we can see the $10 cost for a souvenir remains constant. What changes is the number of souvenirs bought. Well, so then does the total cost. But the idea here is that the $10 cost for a souvenir remains constant, and what changes is how many souvenirs you buy. So we could express that as $10 times X, when X is the number of souvenirs bought, being equal to Y. Now, if we turn that around, that gives us Y is equal to $10 times X, which is in the form Y is equal to KX, which is the direct variation equation. Now, an answer, a good written answer to this would be here. Since the cost per souvenir is constant at $10 each, this is a direct variation. And we can see that each time we found a new cost and we increased the number of souvenirs bought, the cost per souvenir never changed. That's why this is a direct variation. Part B. The cost of a $25 birthday present is split among several friends. Well, if one person, another word for split would be divided. The cost of a $25 birthday present is divided among several friends. Well, what we're going to see, similar to we saw up here, is if we take that $25 cost and we divide it among one person, that's going to be $25 for that one person. If we take that $25 and we split it among 2 people, that's going to be $12.50 per person. If we take that cost and we divide it among 3 people, $25, that's going to be approximately $8.33 per person. If we take that cost and we do $25 cost and we divide it among 4 people, that's going to be $6.25. If we take that cost and we divide it among X people, that's going to be equal to Y, the cost per person. In this problem, we can see what changes is how many people the cost is going to be split upon. The cost remains constant. So as the number of people increases, the cost per person decreases. In this equation here, if we switch it around, is in the form of an inverse variation. Y is equal to 25 divided by X. A good written explanation for this problem is here. Since the total cost is constant, this is an inverse variation. This has been Mr. Pilarski with comparing inverse and direct variations. I hope this video has helped you with your lesson today. Thanks for watching.